In this lesson, we're going to calculate the percentage concentrations and then see how to use these concentrations in calculations. First, we are going to review the definitions of each version of concentration. We have mass percent, which has grams for both the solute and solution. We have volume percent, which has milliliters for both the volume and solution. And we have mass volume percent, which has grams for the solute and milliliters for the solution. Note that there are other relationships or other units that can be used in percent concentrations that are equivalent to these, but these are the ones that we will use. What is the mass percent concentration of methanol in a solution of 15 grams of methanol with a density of 0.792 grams per milliliter in 45 grams of water, which has a density of 1 gram per milliliter? We write out our definition for mass percent, which is grams of solute over grams of solution times 100. When we look at the problem, we see that methanol is the solute because it's present in the smaller amount, and we know the grams of the solute. Now we need to find the grams of solution. The grams of solution is actually equal to the grams of solute plus the grams of solvent. So water is our solvent, but the methanol and water together make up the solution. We plug in the value for 15 grams for our solute and 15 plus 45 for our solution times 100, and we get 25% by mass. What is the volume percent concentration of methanol in a solution of 15 grams of methanol in 45 grams of water? Note that we have the exact same solution described here, but now we're calculating the volume percent. When we look at the definition of volume percent, we see you have milliliters of solute over milliliters of solution times 100. Our values given in the problem are in grams, but we're also given the density so we can convert those masses to volumes. We start with the methanol of 15 grams of methanol. We need grams on the bottom to cancel out, so we use our density. Grams will cancel, and we get 18.9 milliliters of our solute, which is methanol. Next, we have our water, which has a density of 1.00 grams per milliliter. We cancel out grams, and we get that the volume is 45.0 milliliters. So we have 18.9 milliliters of our solute, and we have 45.0 milliliters of our solvent. When we plug the values into our equation, we get 18.9 milliliters over 63.9 milliliters for our solution times 100. Remember that solute plus solvent equals solution, so we have to add the volumes together to get the volume of the solution. When we solve the problem, we get 29.6% by volume. What is the mass volume percent concentration of methanol in a solution of 15 grams of methanol in 45 grams of water? We still have the same amounts of each substance, but now we're calculating the mass volume percent. We define that as grams of solute over milliliters of solution times 100. We've previously determined that the volume of the solute is 18.9 milliliters of CH3OH, and the volume of our solvent, which is water, at 45 milliliters. We can set up our equation by putting the mass in the numerator. We can put 63.9 milliliters in the denominator because that is the volume of the solution, which is equal to the volume of the solute plus the volume of the solvent. When we solve the problem, we get 23.5% by mass volume. Let's compare the different values we got for each type of percent concentration. For by mass, we got 25%, and we can actually rewrite that as 25 grams of solute over 100 grams of solution. This is what the expanded form looks like for mass percentages. For percent by volume, we got 29.6%. Its expanded form would be 29.6 milliliters of solute over 100 milliliters of solution. For mass volume, we got 23.5%, and in the expanded form, we would write that as 23.5 grams of solute over 100 milliliters of solution. Remember that all three of these concentration units are describing the exact same solution. The value depends on the unit. What mass of dextrose is in 375 milliliters of D5W solution, which is 5% by mass dextrose? The density of the solution is 1 gram per milliliter. The first thing we need to do is rewrite our concentration in terms of the expanded form. We're told it's 5% by mass, so we have 5 grams of dextrose over 100 grams of solution. Writing concentration units in the expanded form helps us see the units that are involved because concentrations are a compound unit. The simple unit in the problem is 375 milliliters. So we're going to start our setup with that. We know that milliliters needs to go on the bottom, and we're given the density to convert to mass, so milliliters will cancel. Grams of solution is on top, which means grams of solution needs to be on the bottom of the next step. So we have 100 grams of solution in 5 grams of dextrose. Grams of solution will cancel, and we're left with 19 grams of dextrose. Once we rewrite the concentration in the expanded form, it's much easier to set up our problem just like we have any other dimensional analysis problem.